So today we are coming to continue with Ospf. Teddy, please mute yourself. Teddy, mute yourself, please. We are continuing with Ospf. Last week we saw how Ospf neighbors are formed. Ospf neighbor relationship. We saw the steps. Today, what are we coming to do? At the end of today's class, we should be able to know the Ospf area types. Ospf area types. Last week, we saw the regular area and the backbone area. Today, we'll talk about the stub area. We'll talk about the totally stub area. Then, not so stubby area. And totally not so stubby area. So we have stub, totally stub, not so stubby, totally not so stubby area. After that, we'll talk about the link state advertisement types. LSA. We have different types of LSAs. We have types 1, 2, 3, 4, 5, and 7. By the end of today's class, we should be able to define or identify all these LSA types. Then if there's more time, we will configure virtual links, Ospf virtual links. Okay. So I remember giving you some assignment to do for me. This topology. I'm sure we've all done it. Have we? I know the answer is yes, we have. So what have I done on these routers? The normal configurations, the normal Ospf configurations, the basic ones. Sorry, is somebody sending something on the page? Okay, so let's come to the area 0. Hello? Hello? Is it? Oh, okay, okay. Let me add you. How about you try it? Okay, so the routers inside area 0, the backbone area, I've configured IP addresses on the interfaces, and I've advertised directly connected networks. The basic Ospf configurations. I also advertise these loop back interfaces inside of Ospf. So on router 1, I configured nothing much. I just configured these loopback addresses and advertise them inside Ospf. Then I came to this ABR, did a configuration, that is assigned IP addresses on the interfaces. Then I advertise this network inside area 0 and this network inside area 20. That is how we configure ABRs. I came to area 20 and configured router 8, has some loopback interfaces. Then I advertise all of them inside Ospf, including these connected networks. So that's what I did on router 8. And router 9, I advertised just one network. This router here, let's assume this network is out. So I only advertise one link inside Ospf. This is an ABR. After assigning IP addresses to the interfaces, I advertise just the 2 directly connected networks, one in area 0 and the other in area 10. It's an ABR. Then I came here, this router R5. I realize that this R5 here has a common network with R6 and R7. I hope you remember, broadcast multi-access network. So over here, you know what will happen. These interfaces, one router will be elected as the designated router. Here, that was the criteria. The interface priorities. All these interfaces have interface priorities. The range is from 1 to 255. And by default, all the routers here have priorities of 1. That is the interface priorities, 1 each. So who becomes the winner? The winner will be the one with the highest router ID. So when I was configuring Ospf, I configured router IDs as per their router names. So over here, router 7, router Ospf, let's say 2. I went on to configure the router ID as 7.7.7.7. Okay. So as we established last week, if you don't configure the router ID, then the router itself will choose an ID for A7. How it will choose the ID is to assign the IP address of the highest IP address of an active interface as its router ID. But it's always advisable as engineers to manually configure the router ID. So from what we are seeing here, obviously router 7 here will become the designated router because it has the highest router ID for this small network here, broadcast multi-access. However, if you want to make any one of them, that is router 5 or 6 a router ID, then you have to alter the interface priority. We know how to change the interface priorities. Okay, let's go to the topology. Yeah. So I'm on router 5. Let's show IP Ospf neighbors to check which router is the router, the designated router. So enable configure terminal interface E0/0. I'm turning off the duplex. They have duplex to full duplex. So show IP Ospf neighbor. I'm on router 5. So router 5 is saying that router 7, that is, I manually configured the router ID 7.7.7. And that has become the designated router. Router 6 is a DR adder. Watch here. Where from this router 3? 3.3.3.3. This one here. Is it part? This one. It's not part of this broadcast multi-access network. So between R3 and R5, there's also another type of network here. Let me change the pen. There's also another type of network here. These two interfaces, they will also undergo their own election. Okay, so aside what we have here, these two interfaces will also undergo their own election. A DR will be chosen, and a BDR will be chosen. So we are here. R5 is saying that R3 is my neighbor, and it is a DR. Let's go back to R5. It's a backup DR. All right, so now let's do something. Now that we know that R7 is the designated router, let's force R5 to become the designated router by changing the interface priority of E0/1. Somebody standing? All right. Nobody is here. Who is that? No, nobody is coming. Okay, so let's make this interface, give it a higher priority. That's 5. Let's assign a priority of 10 so that it becomes a DR. Right now it's a DR order. So let's go there. R5. I'm jumping on R5 right now and go on interface E0/1. Configure terminal, interface E01, and the command is IP Ospf priority. But he's not, give him the correct ID. IP Ospf priority, I'm sure he's joining the other one. Let me have a new ID. You see the options are from between 0 and 1. So we choose 10. You have given it a higher priority. Let's save it. After we've done that, I believe we have to clear the Ospf process to refresh it. Okay, and this is how to do it. Clear IP Ospf process for the neighbors to rediscover themselves. So it's asking us whether we want to proceed. We say yes. Now let's confirm again. Let's go on R7. We hope R5 becomes the DR right now. So let's go on R7 and show IP Ospf neighbors. So show IP Ospf neighbors. And R7 has a full relationship with R5 now. And watch. It says what? R5 is DR order. Let's let me come to R7. What's right then? So is he in right now? Because I can't see him. Nobody is coming in. Tell him that Nobody is coming right now. Okay. Why is it choosing R5 as a BDR? It has to be a DR because that one has the highest. Let me go on R6 to refresh. Is it in? Okay. A man error. Oh, call him for me, please. Are you calling him? Okay, so after clearing all the processes, we find out that R5 has now become the designated router. So please, anytime you alter a configuration inside Ospf, you have to clear the Ospf process. So R5 is now the designated router because we altered the priority as 10. Okay. So let's move on. Let's examine the routing table of R10. Bring it. Please, 1 minute. Hello, I did not come inside. Is it? Oh, hold on. I can see some alerts. Hold on. That's not you. Oh. Because I didn't know why the one using the iPhone. Oh, so right now as you're connecting, it's giving you error. Wait. Yeah. Oh. So what do I do? Can you? Oh no! Can you change your ID? Change it. Change the iPhone to your name. Oh. Oh, hold on. Let me. Guys, please give me some 2 minutes to fix an issue right now. No, I don't get any prompt.